Hello everyone and welcome to the module number 3, lesson number 2, interfaces. In this lesson, we are going to learn the topics about interfaces and abstraction, interfaces introduction, interface similarity to a class, interface differences with a class, defining and implementing interfaces, examples for interfaces, properties of interfaces, implementing the interfaces, example for interfaces, example for implementing the interface, Java 8 default method in interface, Java 8 static method in interface, nested interfaces in Java, rules for defining and implementing interfaces, benefits of interfaces, extending interfaces, extending multiple interfaces, tagging interfaces, choosing between abstract classes and interfaces, and the most important points. Let us look at how interface is related with abstraction. Interface is the mechanism to achieve full abstraction or 100% abstraction in Java. Interfaces are the contract between abstraction and its implementation. They can also be termed as the standard to be implemented across different levels or laterals for the declared methods or functionalities. Let us look at the basic introduction to the interfaces. Interface is a reference type similar to a class. It is a collection of abstract methods. A class implements an interface, thereby inheriting the abstract methods of the interface. Along with abstract methods, an interface may also contain constants, default methods, static methods, and nested types. Before Java 8, though the interfaces contained default and static methods, once we have compiled the interface, these default and static methods used to get converted to public abstract methods automatically by the JVM compiler. But since Java 8, method bodies can exist for default methods and static methods, which means it is not compulsory that all the methods in interfaces must be abstract methods. Interfaces can contain methods with body, which means they can contain non-abstract methods also from Java 8. Writing an interface is similar to writing a class, but a class describes the attributes and behaviors of an object, and an interface contains behaviors that a class implements. Unless the class that implements the interface is abstract, all the methods of the interface need to be defined in the class. What is the similarity between an interface and a class? An interface is similar to a class in the following ways. An interface can contain any number of methods like a class. An interface is written in a file with a .java extension with the name of the interface matching the name of the file. The bytecode of an interface appears in a .class file. Interfaces appear in packages and their corresponding bytecode file must be in the directory structure that matches the package name. So let's say if you extend a class into another class, this is how it is shown. Similarly, you can extend an interface into a class, interface into an interface. However, interface extension into a class can be termed as an implementation for us. Let us look at the differences between interfaces and a class. An interface is different from the class in several ways, including that we cannot instantiate an interface directly. An interface does not contain any constructors. All of the methods in an interface are abstract only. An interface cannot contain instance fields, which means instance variables. The only fields that can appear in an interface must be declared both static and final. An interface is not extended by a class. it is implemented by a class. An interface can extend multiple interfaces. How to define an interface? The interface keyword is used to declare an interface. Syntax: interface space interface name followed by flower braces in which we contain abstract methods, static final data members, and flower brace close. Here is the simple example to declare an interface. The file name should be taken as animal.java. Interface animal within flower braces public void eat public void travel. Let us look at another example, which is music player interface. Public interface music player, which contains the methods public void play, public void stop, public void pause, public void rewind, public void forward, public void record. As we already mentioned, interface is like a standard for the industry. So if any of the companies which are trying to create a music player, they must have all these features that are compulsory for a music player. That is the reason we made music player as an interface. Which means if Sony company is making a music player, they must have all these features. If Apple is making a music player, then also it should have all these features. If Samsung is making a music player, then also it should have all these features. That's the reason we say interface is the standard and it must be implemented or it must be used while creating the features of the classes. Let us look at the properties of interfaces. An interface is implicitly abstract. So we don't need to use the abstract keyword while we declare an interface. Each method in an interface which is not declared as default or a static is also implicitly abstract. So the abstract keyword is not needed for the default or the static methods also. Methods in an interface are implicitly public, which means even if you write a method as a default method or a non-default method, they will be made to be public automatically by the JVM. Let us now go through the concept of implementing an interface, which is the usage of an interface. When a class implements an interface, it is thought as signing a contract agreeing to perform the specific behaviors of the interface. If a class does not perform all the behaviors of the interface, the class must declare itself as an abstract class. A class uses the implements keyword to implement an interface. The implements keyword appears in the class declaration following the extends portion of the declaration. Syntax: class, class name, implements, interface name, followed by open flower brace with all the methods of the interface, block of code for the class with a closing flower brace. If you look at the two diagrams here, in the first one, interface A is being implemented by the class B and then class C is extending the class B. In the second diagram, interface A is being implemented by class B. Also, interface A is being implemented by the class C. If you look at the examples, we have class Sony player which is implementing the interface music player, and since we are implementing the music player interface, we have to define all the methods of the music player interface. So we are defining public void play with a method body inside, where I am just printing play method implementation in Sony player. Similarly, public void stop being implemented with the method body. Public void pause, rewind, forward and record methods are also being implemented with a definition for the method body, which is just a print statement mentioning the stop method, pause method, rewind method, forward method and record methods implementation in the Sony player as the single sentence for the print. We then have the public class use interface music player, in which we have the public static void main, where we are creating an object for the class which is implementing the interface. However, by convention, we create object for the interface and give the implementation of the class which is implementing the interface, like interface name space object name is equal to new class name. Here in our example, music player is equal to new Sony player, and then we call the methods player.pause. Let us look at another example for the implementation of the interface animal. The file may be named as mammalint.java. Here we have the public class mammalint implements animal, inside which we have the implementation for the void eat, void travel and public int number of legs methods. Public void eat contains only one print statement where we have the printing mammal eats. Then we have public void travel, whose implementation contains only one print statement mammal travel, and the public int number of legs method has only one print statement return 0. Now this method is followed by the public static void main, and in the public static void main we are creating the instance for the mammalint m is equal to new mammalint and calling the methods m.eat and m.travel. Observe that we are creating the instance for the class against the convention by giving the class name m is equal to new and the class name, instead of giving the interface name then object name is equal to new implementing class name, which is the usual convention. So it is okay to go with the convention, or we can also create the object by giving the class name, which is the implementing class name space object name is equal to new implementing class name, or we can go with the convention by giving interface name space object name is equal to new implementing class name. Either of them would be fine. However, in most of the places, including books and tutorials, you will see the convention which gives the interface name space object name is equal to new implementing class name. Let us look at few points for interfaces which can be done from Java 8 onwards. As already mentioned, since Java 8, we can have method body in an interface, which means apart from abstract method, you can also have a non-abstract method in an interface from Java 8 onwards. But we need to make it default method only. Example, let's name the file name as testinterface default.java, where I have the interface drawable which contains void draw, which is a abstract method, and I have a default method default void message which contains the method body where I am printing system.out.println default method. Now I am implementing the drawable interface with my class rectangle. Class rectangle implements drawable, which contains the implementation for the draw method public void draw system.out.println drawing rectangle. And I have a class test interface default which contains my public static void main, where I am creating the object for the rectangle class using drawable d is equal to new rectangle, and I am calling the methods d.draw and d.message. Once I execute this class or the program, I get the output as drawing rectangle from the implementation of the public void draw, and the default method statement printed from the default void message from the interface directly, whose method we have called in the class interface default. Let us look at one more example. Since Java 8, we can have static method also in an interface. Example, interface drawable contains void draw, which is the abstract method, and static int cube, which takes a parameter int x, and I have the method body return x asterisk x asterisk x, which is the cube value. Then I have the class rectangle which implements the drawable interface, mentioning class rectangle implements drawable and contains the public void draw method, where I am printing the statement system.out.println drawing rectangle. Now I have the class test interface static, which contains the public static void main, where I'm creating the object for the rectangle class using drawable d is equal to new rectangle, and I'm calling the method d.draw. Then I'm also printing another statement where I'm using the cube method, and because it's a static method, I'm directly calling using the drawable interface. So system.out.println drawable.cube of 3. So when I execute this program, I get the output as drawing rectangle, which is the draw method call using the object d.draw, and I'm getting the value 27 for the cube of 3, where I'm calling drawable.cube directly like a static class method. The next concept that we're going to look at is a nested interface. An interface can be declared inside another interface. It is known as nested interface. Example, interface printable, inside which I have void print, which is abstract method. I have one more interface message printable, containing the method void message. So the message printable interface is the nested interface. Let us look at the rules required to be followed while defining and implementing interfaces. When overriding methods defined in interfaces, several rules are to be followed. Checked exceptions should not be declared on implementation methods other than the ones declared by the interface method or subclasses of those declared by the interface method. The signature of the interface method and the same return type or subtype should be maintained when overriding the methods. An implementation class itself can be abstract, and if so, interface methods need to be implemented. When implementing an interface, we have several rules. A class can implement more than one interface at a time. A class can extend only one class, but implementation can be done for many interfaces. An interface can extend another interface similarly to the way that a class can extend another class. What are the benefits of having interfaces? Interface provides a contract for all the implementation classes. So, in terms of interface, it's good to code because implementation classes cannot remove the methods we are using. Since a Java class can implement multiple interfaces at a time, it's better to use interfaces as superclass in most of the cases. The benefit of interface is that it allows multiple inheritance, which is not possible with concrete classes and abstract classes. With interfaces, implements keyword is to be used for implementing. Implements tells the compiler that whatever classes are there after the implementation, they are interfaces. An interface gives template structure of methods from which new classes can be developed easily. Note that an interface can't have constructors because interface won't have any instance fields, so nothing to construct. How can an interface be inherited without constructor? The subclass constructor will usually be calling the superclass constructor. Here we have two cases. First case is when an interface extends another interface. In this case, there is no issue. No interface has a constructor and hence there is no superclass constructor to call. The second case is when a class implements an interface. In this case, there is no inheritance because class implements interface and do not extend the interface. Let us look at the concept of interface inheritance, which is interface extension. An interface can extend another interface similar to the way that a class can extend another class. The extends keyword is used to extend an interface, and the child interface inherits the methods of the parent interface. In the next page, sports interface is extended by hockey and football interfaces. For example, public interface sports contain these two methods: public void set home team with parameter string name, public void set visiting team with parameter string name. We have another interface, public interface football extends the sports interface. Now the interface football contains these three methods: public void home team scored integer points, public void visiting team scored integer points, public void end of quarter int quarter. And also public interface hockey also extends the sports interface, and the hockey interface contains these methods: public void home goal scored, public void visiting goal scored, public void end of period int period, public void overtime period int OT. Let us go through the explanation. In the example shown in this page, the hockey interface has 4 methods, but it inherits 2 from the sports interface. Thus, a class that implements hockey interface needs to implement all the 6 methods from the hockey as well as sports interfaces. Similarly, a class that implements football interface needs to define the 3 methods from the football and the 2 methods from the sports interface. Extending multiple interfaces. A Java class can only extend one parent class. Multiple inheritance is not allowed for the classes. But interfaces are not classes. An interface can extend more than one parent interface. The extends keyword is used and the parent interfaces are declared in a comma separated list. For example, if the hockey interface extends both sports and event interfaces, it should be declared as public interface hockey extends sports, event. Note that multiple inheritance is not supported in case of classes because of ambiguity, but it is supported in case of interfaces because there is no ambiguity, as the implementation is not provided by the interfaces but they are provided by the implementing classes. Let us look at the concept of tagging interfaces. The most common use of extending interfaces occurs when the parent interface does not contain any methods. For example, the mouse listener interface in java.awt.event package extended java.util.eventListener, which is defined as package java.util public interface event listener. An interface with no methods in it is referred as a tagging interface. There are 2 basic design purposes of tagging interfaces. The first one, it will create a common parent. As with the event listener interface, which is extended by dozens of other interfaces in the Java API, you can use a tagging interface to create a common parent among a group of interfaces. Now the second one is that it will also add a data type to a class. This situation is where the term tagging comes from. A class that implements tagging interface does not need to define any methods since the interface does not have any, but the class becomes an interface type through polymorphism. How should we choose, or what should we choose? Abstract class or an interface? We have to consider these things before choosing between abstract classes and interfaces. If you want to consider using abstract classes, if any of these statements below apply to your situation, then use abstract classes. If you want to share code among several closely related classes, you expect the classes that extend your abstract class have many common methods or fields or require access modifiers other than public, such as protective and private. You want to declare non-static or non-final fields. This enables you to define methods that can access and modify the state of the object to which they belong. You can consider using interfaces if any of the below statements will apply to your situation. You expect that unrelated classes would implement your interface. For example, the interfaces comparable and clonable are implemented by many unrelated classes. You want to specify the behavior of a particular data type, but not concerned about who implements its behavior. You want to take advantage of multiple inheritance of type. Now, because we have completed the topics about interfaces, let us go through a few of the important points that we have gone through till now about interfaces. Interfaces are implicitly abstract, so they cannot be instantiated. If you want to define the non-static function in an interface with a body, then you have to make it default by using a default keyword. Default keyword can be used only within an interface. If you give only the prototype of any method in an interface, then by default it will become public and abstract. A child class can implement more than one interface simultaneously. If a child class is having same default method from more than one interfaces and the child class has not overridden that method, then it is a compilation error. If a child class is having a same abstract method from more than one interfaces, then it has to override once. One interface can extend another interface. If one interface is extending the another interface and it is getting the same method from a parent interface which are already defined in a parent interface, then priority always goes to the method of the child interface. One interface can extend more than one interface simultaneously, and this is the situation we can say in Java there is multiple inheritance in case of interfaces.
Thank you.